In this section, we will discuss how to define, create, and run threads in Python. Let's get started. The Python threading module is the Python library to support the implementation of multi-thread application in Python. The threading module provides the interfaces to manage threads within a Python application. These interfaces include methods for starting, pausing, resuming, and stopping threads. The Python threading module is heavily inspired by Java threads. So, if you're familiar with Java and Java threads, you will adjust to Python threads quite easily. Also, the threading module offers synchronization capabilities between threads. This includes primitives such as locks, semaphore, and condition variables. We will discuss this concept in detail in the following during this class. Let's start by discussing how we can create a new thread in Python. There are a variety of ways you can create threads in Python. The most popular approaches are the following. First, you can create a thread instance passing in a function that implements the business logic of the thread. Second, you can subclass the thread class and create a subclass instance. This instance implements the thread business logic. You can choose the approach that fits best your need and coding habits. However, if you implement threads by subclassing the thread class, you can probably obtain the best results. You can probably produce simple and clean code that you can easily manage in the future. Let's get our hands dirty. It's time to create our first thread. We start by creating a thread instance passing in a function. Well, in order to do so, we have to follow some few steps. Step 1, we have to create an instance of the thread class. Step 2, we have to specify the name of the function that is going to implement the logic of the thread. Step 3, we have to call the start method, and this will spin up the thread. And step 4, we have to wait for the thread to finish by calling join. Let's start by discussing the thread class. The thread class is part of the threading module. The thread class represents an activity that is run in a separate thread of control. Once a thread object is created, its activity must be started by calling the thread start method. This invokes the run method in a separate thread of control. Once the thread activity is started, the thread is considered to be alive, and it stops being alive when either its run method terminates normally or by raising an exception. This is the constructor of the thread class. You can see you can pass in several arguments. First of all, there's the group. Group is reserved for future implementation. The value of group should be none. Then you can pass in target. Target is the function that implements the thread logic. We will use it to pass in the thread logic of the logic of the thread. Then you can specify the name of the thread. A default name is always associated to a thread, so if you don't pass in anything, your thread will be named as thread n. So basically the first thread will be thread 1, then you have thread 2, 3, 4, 5, n. Then you have the args. This is the tuple of argument that will be passed to the target function, to the function that you passed in as a target. because you may have to pass in arguments to a thread, for example, to set up some initial value, to adjust its behavior. Finally, you can pass in a dictionary of keywords that are used for the target, keywords. As we said before, once a thread is created, its activity must be started by calling the start method. And this method invokes the run method in a separate thread of control. Now, let's have a look to this method. So the start method is in charge of starting threading activity. It must be called at most once per thread, and it arranges for the object run method to be invoked in a separate thread of control. And the run method actually represent the thread activity. The standard run method invokes the callable object passed into the object constructor, if any, and pass to the target all the argument that we passed in from arg and keywords. Finally, we have join. Join waits until the thread terminates. This blocks the calling thread until the thread whose join method is called actually terminates. And the thread actually terminates when its method run terminates, or when an exception is raised. When the timeout argument is not present, or the timeout argument is none, the operation will block until the thread terminates. For an indefinite amount of time, we wait. When the timeout argument is present and is not none, it should be a floating point number specifying a timeout for the operation, and it is expressed in seconds. Let me stress that other methods are of course present in the thread class. We did not cover now in detail, we will discuss later, and you can have any detail about all this method by reading the Python documentation. Here we have the very first example of multi-threading application in Python. Before getting into the detail of the code, let me just say that the goal of this function is very simple. Our goal is to create a new thread. The thread is expected to wait 2 seconds, and after these 2 seconds it prints out, hello, I am your new thread on the screen. Then that thread terminates. That's it, as simple as that. So let's get starting. Let's analyze the code. First of all, myThread function. This function is really easy. Everyone understand it. We sleep 2 seconds, then we print hello, I am your new thread, and we print it on the CLI on the screen. And then we have the main where the thread creation logic is implemented. As you can easily see, the first step is the creation of the thread class, and we pass to the thread class the function myThread function as the target. This tells the thread class, that the business logic of the thread will be implemented by the myThread class. The second step is to invoke thread start method. This activates the thread. After we execute thread start method, the thread is alive and it actually starts running. finally, we need a join. We need to call the join method of thread to be sure that the main thread, the thread running the application, the main of the application, waits for my thread, the new thread we implemented, to terminate. So, very easy, very easy. Let's do a very simple recap. First, we define myThread function. This function implements thread logic. Second, we instantiate thread and we passed in myThread so that the new thread will run the application logic, the thread logic defined in myThread. Third, we activate the thread. We run the thread, and we do this thing easily by invoking the start method of thread. Finally, we wait for the thread to complete with a join. Very easy, very straightforward operation, and there's not much to add. Now we see the results of our application. Let's run our application. We start the application from the command line very easily, and the output is what we expected. So we create a new thread, we run the thread, then the main thread prints out, I'm waiting for the new thread. And we start executing in a concurrent way. Then what you can see is that our thread prints out, hello, I'm your new thread, and terminates. The main thread is waiting for the thread to terminate on the join, then can print the thread has completed its execution. So everything is what we actually expected. So far, so good. Everything seems fine. Let's make things slightly more complicated. Let's try to pass parameter to the thread function. So our idea is to pass myThread function, the text of the message to print, and the number of seconds to wait. So let's see how the code changes. Now the myThread function takes a couple of arguments. Message is a string, and delay should be an integer number expressing the number of seconds our thread is expected to sleep. The rest of the code is pretty much the same. So we add thread, we instantiate the thread, and we pass the target as a target the function. But here there's a difference. Basically, we can't pass in arguments, and we use a tuple to pass the argument. Let me say that the order of the arguments in the tuple is the same of the arguments that are passed to my thread. So as you can see, the hello there string will be passed as message to the myThread function, whereas 1 in the arguments will be passed as a delay in seconds. Everything is the same beside this little difference. So we still have to call the start method and to wait for the thread to complete its execution through thread.join by calling the join methods. It's time to run our application. We use the command line to run the application, and the result is exactly what we expected. So basically, after running the application, we write I am waiting for a thread. Then after 1 second, the application, I mean, the thread we spin out, we run, prints hello there and terminates. After the thread terminates, the main thread, which is waiting for this thread on a join, can terminate as well. That's it. So it's very, very, very simple. Let's now consider another example. The goal of this example is to show you how you can create a number of threads and how you can run them and manage them. The logic of the thread is defined by the myThread function. The myThread function has an input parameter, the number, and the logic is quite simple. Basically, it prints I am thread number with a number that was passed into the function. Then the function sleeps a random amount of time between 0 and 2 seconds. Then the function prints I am thread number and I'm done. So it's quite simple. The interesting part of this code is into the main function. First of all, let's start by considering this list, the thread list. The thread list will contain thread objects that are necessary for the management of the different threads. So it's very important to have this thread list. Then let us consider the cycle, this for cycle. We have 5 iterations, and for every iteration we create a new thread and we append the thread to the threads list. What's next? After we have created threads, we must run them. And in order to do so, we have to invoke the start method. In our example, we have the threads list containing all the thread objects. As a consequence, in order to start all the threads, we need another loop. And for every iteration, we need to start a new thread. And of course, in order to complete our job, we need to wait for all the threads to terminate their execution. And this can be easily implemented through the join method. As we see in this code, the join takes no argument, so it does not take in any timeout argument. All the joins you see here are basically blocking primitives. So in this code, for every cycle, we are waiting for a specific thread to terminate. And the effect of this section of code, of this for loop, is really simple. We exit the for loop only when all threads terminate their execution. So let's have a quick recap of this simple code. First of all, we have the myThread function that implements the simple logic of the thread. Then, important, we have a threads list. The threads list is in charge of providing support for the management of the different threads. Then, easy, we have to create threads as usual. The difference with regards to the example we discussed before is that now we don't need to create a single thread but 5 threads. So we have a cycle to create them. Similarly, we don't have to start a single thread, but we have to start 5 threads. And consequently, we need a cycle. And we also need a cycle to wait for all the threads to terminate their execution. Now, let's see our simple code at work. Very, very good. So now we have some idea how we can create threads using functions. So we learned that we can build a thread and we can implement its logic within a function that we can pass in the thread class. This is a way to implement thread. But we said this is one of the possibilities we have. We can do maybe we can do better. We can do better with regards to the possibility to manage and maintain the code if we can implement threads with an object-oriented approach. That's what we are going to discuss now. Basically, we are able to create a new subclass instance of the thread class, and this subclass can implement the thread logic and can be run and can be updated, modified with the ordinary object-oriented approaches to code development. This is very important as this reduces the number of issues we have in the code. It makes the code easily reusable and so it improves the quality of our work. But this discussion is kinda outside the scope of this class. There are excellent classes on software engineering and object orientation that will discuss in detail all this stuff. Just a little note, you may consider so-called solid principles that are very useful for the design of good quality object-oriented code. Here, let's get back to multi-threading and how can we create a thread by adopting this approach? Well, it's very simple. Basically, we first have to create a subclass of the thread class. Second, we have to override the run method of the thread class. So it's something very easy for anyone who is familiar with object orientation. And then, as usual, we have to run the thread by calling the start method. As usual, it's not different from what we are used to do. And of course, we always have to wait for the thread to finish its work by calling join on the main. Well, this is a simple code example that is meant to show you how you can implement a thread by subclassing the thread class. We will see this code in detail and we will analyze the different parts of this code, so don't worry. This is the code of the myThread class that will implement the thread logic. MyThread class is a subclass of the thread class. The class constructor in it is used to set up the class and its attribute. Of course, here we are in Python object orientation realm. So everything that is valid in Python is also valid here when it comes to attribute, scope of visibility, and etc. etc. In this case, we have two attribute, and this attribute can be used for the implementation of the logic of the thread. So basically, we are the thread parameter that we pass in the thread class. That's the basic idea. That's the basic idea. And as you can easily understand, the code you end up writing in this approach tends to be quite more readable, quite more manageable, easy to evolve with the time. The actual logic of the thread is implemented by overriding the run method. In this case, the logic is extremely simple, as we simply sleep for some time defined by the self-duration attribute of the class, and we print a message which is passed in to the constructor. So basically, we can use this attribute to manage and implement our logic for the thread. So very, very simple, very, very easy approach. Okay, if everything seems to be clear, now we can get back and understand how things change when it comes to using the thread, managing the thread, running the thread, joining the thread, and so forth. So we are back, and we can read the whole application code in this slide. And our goal now is to understand how we can create, start and join a thread. Here, for the sake of presentation simplicity, we consider just two threads, T1 and T2. First of all, we have to create a thread. How can we create a thread? A thread is an object. It's as easy as usual. So how can we create a class instance? Easy. We invoke its constructor. In this case, we have this my thread. We pass in, first of all, a message and a number, a duration in seconds. So the message is for the first thread is I am T1, and the duration is 2.7 seconds. For the second thread, the message is I am T2, and the duration is 1.3 seconds. Let me note that, as usual, it's important to have some variable which is in charge of enabling us the interaction with the object. So we create the instance and we assign it to some variable. The first thread is assigned to T1 and the second to T2. Very simple. It's not that different from what we do in the previous examples. It's a very similar concept. Here, the only difference is that we are using the capabilities provided by object orientation, and we are invoking a thread with its constructor. That's it. How can we start the thread? As usual, we have to invoke the start method of thread. That's it. It will be the start method which is in charge of invoking the run method and to actually start up the thread. So very simple. In order to start thread T1 and thread T2. Very easy. We have to invoke method start on T1 and method start on T2. That's it. It's very, very simple. It's no, I see no different from what we did in the past. Finally, we have to wait for the threads to terminate their execution. How can we do so? As usual, with join. Join is a blocking method. The thread that calls join waits until the thread it is waiting for terminate their execution. Basically, in our example, we have, I tell you the truth, we have 3 threads. We have this called main thread, and the main thread is in charge in this application of creating the threads, of starting the threads, and waits for the threads to terminate their execution. Basically, the main thread reaches T1.join and blocks. As long as T1 is executing. When T1 terminates its execution, the so-called main thread can move to T2.join, to the following instruction. And when it does so, it stops as long as T2 is still running. When T2 terminates the execution, okay, we can move on, and also the main thread can terminate. That's how it works. So let's have a very simple recap of what we have seen in the last few slides. Basically, we have 2 different ways, 2 different approaches to define and create a thread. The former approach is creating a thread by passing in a function to the thread class. It's a possibility. The second approach, the latter, which is the approach we follow here, is to subclass the thread class and to override the run method in order to implement the thread logic. It's important to stress that the subclass constructor can be really useful for passing in thread parameters. And it's very important to say again that everything that is used in ordinary Python object orientation, every practice, every design guideline can be applied to multi-threading as well, to the definition of thread as well. That's very, very important. So now it's time to see our code in action. Let's make a little recap of what we have discussed so far. In this section, we discuss how we can create a thread in Python. So, the concept of thread is getting more and more familiar, and this is very important. In particular, we discuss how we can create thread, and we discuss about the opportunity to adopt different approaches. We can pass in a function to the thread class, or we can easily subclass the thread class. We discuss about the difference in terms of software engineering with regards to the different approaches. And we also show how we can create a multiplicity of thread, and we can control a multiplicity of thread by using normally lists. So I think it's time to start using thread for something more complex.